I'm here today to tell you about the most exciting technology that I have ever seen that enables many multi-billion-dollar markets that you'll see, and how we're turning that into a business in Hummingbird Nano. The best way to describe the technology, if you look at this video, you've ever seen the movie Terminator 2. In that movie, there was a robot. That robot would start out in a liquid state, a liquid form, and he would shape-shift. Then he'd turn into a solid. And then he would turn back into a liquid, and he'd shape-shift again. And then he'd turn back into a solid. And that is exactly what we do with our revolutionary 3D manufacturing platform that's patent protected and invented at Hummingbird Nano. Our team is all here in the back in the corner. Say hi to them if you get a chance. We've got the inventor of the technology, Eleanor Hawes. We've got a Stanford University graduate and 15 years experience in Silicon Valley, Candace Gillette. And from Chicago, with an MBA from Booth School, is Tony Olivito. And we're also supported, very importantly, by a team of successful business builders that are nationally known. Our innovation, as I said, is a manufacturing platform. That means we can manufacture many different types of products. The first vertical that we've chosen to go after is a microfluidic chip to enable the revolution promised by portable medical diagnostics. The reason we chose this product is it's the easiest to implement with our system. Number two, it's got a super large market, $3.6 billion annually, and we have the most number of competitive advantages with this particular product. If you don't know what a microfluidic chip is, very easily, if you think about chemistry class and a microscope slide, you've seen it before. Think about that microscope slide with a channel going through it, or several channels that are about the size of a human hair. We can inject a sample in that, and then we can use that slide to do all sorts of chemical analyses with it, like DNA testing, mixing, evaporation, and titration. Microfluidics has been named one of the 10 technologies that will change the world. As an example, if we think about malaria, tuberculosis, and age diagnoses, these plague the third world countries. We also think about rapid testing for cancer, and we can address that with our technology, but it's not being addressed right now. Why not? Well, because there's a gap in the manufacturing technology. These are the three manufacturing technologies used to manufacture microfluidic chips. Injection molding, very fast. It's great if you want to produce the same thing over and over again, but it's very expensive to do. 3D printing, it's not good enough yet. It's got poor precision, it's slow, there's no tooling. And then you have surface machining, which is what we probably compete with most, but it's slow and it has expensive equipment as well. Our solution, configurable liquid mold technology. Step one, we shape the channels that go through the chip. And if you see those black dots, that represents a fluid that forms a channel. We use a magnetic field to shape that. The green material represents the chip material, and in step one, it's a liquid as well. And so those channels are actually suspended inside of that green material. Step two, we cure the chip material. That means we make it hard. Step three, we take the magnetic field away, and all we have to do is drain the ferrofluid out, and we're left with a microfluidic chip. And we're actually doing this at our facility out on Jackie Fox Way. On the bottom, we see a T-style chip from Hummingbird Nano. On the top, we see a competitor's chip. And on the left, we see the first chemical detection using a Hummingbird Nano chip. So we verified that this works. What's our sustainable competitive advantage? We're faster when we manufacture these. The chips we make are stronger. They're more precise. The procedure is more flexible. And it's very inexpensive. What this adds up to is disruption in the marketplace. Marketplace, $3.6 billion market. And the gap that we're going after is the 1 to 1 million chip per year market at a reasonable price point, which does not exist. We're going to manufacture and sell those chips through channel partners and direct to lab users as well. And this is a list of our go-to-market activities, which span the broad spectrum of what you need to be a successful business. And finally, what kind of traction do we have to date? We've received over $1.5 million in grants, mostly from the National Science Foundation and matching grants from the state of Kentucky. We've also received $500,000 in equity investment, and it's all going to our first product launch, 3/1/2018. I'll be glad to take some questions. Thank you.